I will present our paper called Do Your Best and Get Enough Rest for Continual Learning. In this paper, we introduce Ebbinghouse's forgetting curve theory. As shown in this figure, he established well-known theory called forgetting curve, which says human memory tends to fade as time is going on. However, memory retention can be improved by repeated learning in a optimal recall interval. To provide an intuitive understanding, we provide an illustrative example where two persons learn 10 words in February, and after 6 months, two persons are tested for how many words they still remember. For the person A, he memorized 10 words in every 2 days, and after 6 months, he only remembers 3 words. However, for person B, he memorized 10 words every 4 days. After 6 months, he still remembers 10 words. We believe the differences in the results come from the differences in the relearning intervals. And we apply this theory to neural networks in continual learning scenarios. Now I want to describe the main theory in more detail. The main theory is to expand the recall interval to improve long-term memory retention of neural networks. We want to describe it with the following figures. In figure A to C, x-axis means the elapsed time, and y-axis means memory retention. As time passes, memory retention decays, but it becomes high again when we recall it. This pattern repeats until we finally don't recall again. When we stop recalling, it decays at a fast speed. How can we prevent it? As shown in figure B, recalling with an optimal time interval is important to keep memory retention decay as low as possible. Since long-term memory ensures moderate difficulty, it can ensure relearning items successfully. However, when this recall interval becomes excessive, it becomes too large and the memory retention decay becomes fast again. Figure D provides this linear relationship between recall interval and the degree of forgetting, which indicates that the optimal recall interval has a moderate degree of forgetting. To have an optimal recall interval, we propose view batch model. We structure a view batch which has multiple views of a single sample. As the size of the view batch, the recall interval of a single sample increases. Figure A shows the baseline method. It trains whole samples which are marked as different colored circles for each sample, resulting in recall interval as 1. However, the proposed view batch model trains 4 views of a single sample which are indicated as differentiated circles for each sample. Thus, its recall interval is increased by 4 times. Through this method, we can adjust the recall interval. Furthermore, with the proposed SSR algorithm, we extensively learn the augmented views of the sample. Using the proposed method, we investigate how the recall interval affects the learning behavior of the neural network. In figure A, x-axis means the different recall interval and y-axis means degree of forgetting. As shown in the green line, the degree of forgetting increases with the recall interval. In figure B, x-axis means the elapsed time and the y-axis means the memory retention of task 1. Before 170 epoch, we train task 1, and after it, we do not train task 1, we only train the other tasks. As we can see in the red line, it decays more slower than the other recall intervals. In figure C, we demonstrate that 3 times achieves the best performance thanks to the slow memory retention decays. Provide comprehensive comparisons of various factors for continual learning. TCIL is used as a baseline method on the SciPy 100 dataset. Red bar means our method, and the gray bar means the baseline method. As we can see in those figures, the proposed method works really well compared to the baseline method. As a conclusion, our main contribution is to propose the view batch model that optimizes the recall interval between retraining samples in order to enhance memory decay in the continual learning tasks. The main benefits of the proposed method is the effectiveness of our approach on various state-of-the-art continual learning methods, where ours consistently improves the performance of the baseline method. The main drawbacks of the proposed method is the limited experimental scope to the continual learning tasks.